get into any of the science talk, guys, I want to do a small demonstration. So I'd like everyone to take their right index and middle finger. I want you to try and find your pulse on your left wrist. If you're having trouble finding it, you could flex your wrist, and if that doesn't help at all, you can try and find it on your neck. Really pay attention to the speed at which your heart is beating. Maybe take a deep breath. Good. Everyone can take their hands off their pulse. Now, I'd like you to close your eyes. And I want you to visualize the most stressful thing going on in your life right now. It could be presenting your thesis on thesis day, or it could be an important meeting coming up. Really engage all of your senses. Put yourself in that scenario. Good. Everyone may open their eyes, and let's try and find our pulse one more time. Now, most likely it's the case that your pulse sped up. Indeed, there's an association between the activity of your heart and your well-being, whether that be physical or mental. Now, I wanted to try to apply that in police for a moment. Police face a disproportionate amount of stress by virtue of their careers. They are constantly expected to make snap decisions, often or sometimes in life and death scenarios. And as a consequence, they have an elevated risk for a whole host of things, such as suicide, developing PTSD, a whole host of things that may not even be included on this slide right now. But I want you guys to think for a moment, why does this matter? Why should we care as individuals who aren't officers? Well, I'm gonna make two suggestions. One, I'm gonna make the bold assumption that we're all empathetic people in this room, we care about the well-being of others. Two, I'll submit that this is a matter of community well-being. Research has shown that officers who have elevated levels of stress, anxiety, we can say poor well-being, are more prone to committing occupational errors and even lethal force errors. This has implications for communities at large, and it begs the question, what strategies do we have to screen for well-being? I've listed off a few physiological and psychological methods here, but quite frankly, these are costly, time-consuming. There is an emerging method that's less costly and less time-consuming, and it's called heart rate variability. Now, heart rate variability is a measure of the beat-to-beat variation of your heart in a given time frame. High HRV at rest is characteristic of a healthy person. And I'm sure intuitively we all understand this on some level, but just to put it into words, you can think of the variation of your heart at rest to be a reflection of your ability to adapt to your changing environment. And so, low levels of HRV have been associated, at rest, have been associated with a whole host of physical and mental illnesses. So this makes it a desirable measure for the pursuit of measuring well-being, and also really desirable for police research as well. And by my estimation, it has been in the literature for for more than 20 years now. But there are a few important things we need to keep in mind here. One, in all of that time, there has been no effort to categorize police physiology at rest compared to the general population. Additionally, as it's been increasingly used in the field, there have been concerns pertaining to its reliability. HRV is most reliably used in clinically controlled environments. Police research is done in the field. And so things like movement and breathing really affect HRV. Luckily enough, and this is the last left turn we're going to take here, there is a measure that has emerged that claims to be more robust than traditional HRV and prone to less confounds. It was developed by a group of researchers at Harvard University. It's called heart rate fragmentation. It's a measure of the change in acceleration between each heartbeat. I want you guys to think of a car for a second. You're never advised to stomp on the gas like a professional F1 driver or stomp on the brake. It's not good for the machine, and quite frankly, it's not good for your gas consumption either. In this economy, that's a whole other story. Everyone who went to the gas pump this morning, you guys know what I'm talking about. But anyways, you can apply the same logic to your heart. A heart that tends to abruptly increase and decrease in speeds, like this choppy diagram is showing us, is unhealthy. And in this framework, it's called high levels of fragmentation. Conversely, a heart that steadily increases, steadily decreases in speed is called fluency, as what this diagram is trying to show us, and that's what's healthy. So these researchers tried to compare their measure with HRV to see how it stacked up. They looked at individuals with coronary artery disease and healthy individuals. So let's see what they found. So this is their graph of HRV. The red bars are those with coronary artery disease, and the blue bars are those who are healthy. The distributions are almost identical. However, the story changes when we look at their measure, fragmentation. You can see the clear difference in peaks and the separation. In light of this evidence, we decided that this measure could be applicable to our research, and that's exactly what we're going to talk about today. Here today, what we're looking at is police physiology at rest using HRV and HRF in police compared to the general population. We have a few predictions before we get into further discussion. One, that both HRV and HRF will show differences in police relative to the general population. Two, that HRF will be more robust than HRV in differentiating the groups. And three, we're going to have a sub-analysis of tactical versus frontline officers. Tactical, you can think SWAT team. It would be, in my opinion, a mistake if we did not make this distinction. These two groups are quite different. Tactical officers have more rigorous training and constant training throughout their career. They have higher physical expectations put on them. Frontline officers go to the academy and then they serve. There's no real expectation of further training than that. So how did we get to the answers that we wanted? This was a secondary analysis of police data collected almost over a decade by the Heart Lab. We got our healthy sample data from a large database from the University of Rochester, and I just want to hit this point home one more time because the literature we discussed in the introduction revolves around this. We are looking at their physiology at rest, so everything we're going to see is a 5-minute resting window. All right, without further ado, what exactly did we find? Let's start with HRV. So here's the bar graph of the means of each group, their distribution. The error bars are 95% confidence intervals. And right off the bat, I'm sure you guys can tell the similarity of this distribution graph with previous research. The distributions are almost identical. Indeed, there are no significant differences between our groups under HRV. We also have graphs here for mean heart rate, which is another form of HRV. The stars here denote significance. And we can see that the distributions are a little more separate. And despite having significance, I want to make sure we look at this in context. The groups here are all within what's considered healthy for an adult for their mean heart rate, their BPM. So nothing really meaningful to yield here either. Let's take a look at our HRF data. So first, fragmentation. Again, the stars denote significance. And there's a stark difference between the distributions. We can see different peaks, and there's a lot less overlap than our HRV measures. Similarly, again, with fluency, we have the same story. And before we move on, I want you guys to really pay attention to the pattern of significance here. The blue bar, tactical, and green bar, general population, are not significantly different from one another. The frontline officers are significantly different than both these groups. They have higher levels of fragmentation and lower levels of fluency. Okay, we talked about a whole lot. Let's try and bring our minds together to really come away with what this data is telling us here. So we looked at police physiology at rest using HRV and HRF. Here we put forth more evidence that suggests HRV may not be so reliable in the field. On the same note, we also put forth evidence that HRF may be or is robust enough to differentiate these groups in this setting. We also had this distinction between tactical officers and frontline officers. We talked about their training, so that could be playing into why there's a difference here. You guys also might be curious to know that frontline officers report higher levels of subjective stress than tactical officers. So there's a lot of moving parts to the difference in these two groups, and really understanding these differences may help inform training regimes for frontline officers moving forward. A limitation I do want to acknowledge is that the body position of our participants. For the data we got from the open database, we were told that they were lying down during their resting period, whereas our officers were instructed to sit up. This may have influenced the HRV data, but it's important to look at this in context as well. The literature here tells us the difference between these two body positions is minimal, but nonetheless something to acknowledge.